The next area I'm going to consider is the effects of wind. Now, where natural ventilators are used for smoke extraction, it's important that they are positioned where they will not be adversely affected by external wind conditions. Now, positive wind pressure can be much greater than the pressures developed by a cooler smoke layer. And if this occurs at a smoke exhaust opening, the ventilator may act as an inlet rather than extract. In other words, if the force pushing it out is less than the positive pressure above it, the wind for example, what happens is it's not going to push it out, it's going to push it in. However, if the ventilator is sited in an area of negative pressure, negative wind pressure, then the resultant suction force will actually improve the system, will actually improve it. So obviously if you've got smoke coming out and you've got negative pressure above it, it will actually speed up the process and actually increase the rate of exhaust. Now, the effects of wind pressures on a ventilation system are not isolated to localised wind pressure effects alone. Now, the wind pressures around the entire building envelope, for example, the global pressures, will dictate the smoke flow patterns within the building and the effectiveness of the ventilation system design. Now, there's a number of problems that you may encounter when considering the effects of wind. However, they can all be overcome. Now, the ventilator may require modification, relocation, or you may have to replace natural ventilators with mechanical ones. That's what you may have to do. I would like to note, however, that you cannot have natural vents and mechanical vents in the same reservoir. So you have one or another in the same reservoir as it is. You can't have them both. Now, for complex building structures or buildings that may be significantly influenced by the topography of the surrounding structures, for example, those in city centres, it may be desirable to carry out a wind pressure study by one or a combination of the following. First of all, you could consult a wind specialist to carry out a desk study. You could commission a wind tunnel test in conjunction with structural engineers. Or finally, you could carry out a CFD analysis. So that's what you can do. You don't have to, but you can. Now let's look at the potential problems that you may encounter. Now, all natural ventilators have the same potential problem, as their performance can easily be affected by adverse weather conditions. And this is especially the case when back pressure is generated by surrounding buildings. Now, as you can see here, if wind hits a taller building adjacent to the roof of the building where the natural ventilators are going to be fitted, then you will get a back pressure. Can you see here the back pressure? This can be created, and this will adversely affect the ventilator's effectiveness. So what are the rules? Well, it's generally accepted in the industry that you should not locate any natural ventilators within a distance of 3 times the height of the building. As you can see here, wherever that height is there, you shouldn't locate any natural ventilators within 3 times that height on that particular one. So if the height of the building here was 5 metres, then there's no natural ventilators should be located within 15 metres of that edge there. If it's 7 metres, then you've got 21 metres. Now, if ventilators are required in these areas, which in tall buildings they will be required if there's got a tall building next to it, then fan-assisted ventilators would be required. In other words, you can't get away with natural ventilators, you may need mechanical ventilation. However, as I mentioned earlier, the industry recommends that you should not have natural and mechanical in the same reservoir. So the problem is, in those areas, if you can't get away with natural and you need mechanical, well, that whole reservoir should have mechanical rather than mixture of both.